Welcome back. Now we're going to evaluate, and actually we're going to solve some equations with sine and cosine functions as well. So these first four questions are just a little bit of review. It's just to see if you remember the difference between big arc and little arc. So remember, big arc just means the principal value. Little arc means the general value. So I would like you to pause the video and try these four questions round to the nearest minute, and they're just calculator problems. So go give them a try. So check your work. You should have 80 degrees and 49 minutes for number one because it's just the principal value of that problem. Number two, same, just the principal value, so 66 degrees and 55 minutes. Number three is the general value for cosine, or cosine of 0.4762, so that means cosine is positive in the two right quadrants, so you needed 61 degrees 34 minutes and 298 degrees 26 minutes plus 360k. And little tangent is 44 degrees is 29 minutes plus 180k, because remember, tangent repeats itself every pi, not 2 pi, so you only need that one value plus 180k. Okay, so where we're going to go from here is we're going to be solving trig functions similar that way. We are going to use to find infinitely many solutions, but this time we're going to use our little arc in our calculator to find the infinitely many solutions. So how are we going to do that? Well, I'm going to step you through two problems, and you're going to try two problems, and we're going to see how you do. So basically what you're going to do is you're going to find the given function value for part A, and then for part B you're going to find the general values for f of x equals 0.5. How are we going to do that? With our graphing calculator, of course. So the first thing you really want to do with these, though, is you need to set up your window. So you need your amplitude, you need your node, and that's going to give you your y max and your y minimum. So the amplitude is 1, your node is y equals 0, so that means you have a crest of 1 and a trough of a negative 1. Your crest is your y max, and your trough is your y min. So now we have to go find our x max and x min. Well, that's going to be our start and stop values. So that takes us back to 0 is less than or equal to x, which is less than or equal to 2 pi. And this one's done because we're not doing anything with the x. We're not multiplying it. We don't have a horizontal shift or anything like that. So this is just an easy example. So this start is going to be your x min, and this is going to be your x max. So we're going to use that in our calculator in just a minute. So a couple other things you got to think about. We're going to be working in radians, so make sure your calculator is in radians. And then you're going to go to your y equals, clear anything that's in your window, and type in sine x. Close your parentheses, and then you can click graph and see what it looks like. And you can see that it's going to work forever and ever and ever. That's what a typical sine wave looks like. Repeating itself every pi, that's why you can see, or every 2 pi, you can see a little after 6 how it starts to repeat itself again. So how do we find f of 3? Well, we just press second table, and we just go to 3, and we see that the answer is 0.1411. So when we have the x value, we just look at our table, 0.1411, and we are done. But how are we going to find the other values? Well, we want the two values that fit in the start and stop window. So we go to our window. Our x minimum is 0. Our x maximum is 2 pi. So 2, and then you can just use the pi symbol, and you click enter, and it'll automatically convert it to a decimal for you. Your y minimum is a negative 1 based on your trough, and your crest is your y max, which is a positive 1. So now when you press graph, you get to see just the one cycle we need. So how does that help us find the values? Well, now all you have to do is go back and click y equals, and in y2 you enter the 0.5. And then you press graph, and I'm sure you can imagine from there you're just going to find the intersections. So when you press your second trace and you go to your intersections, you must find both. So number 5, intersect. We're going to take our little blinky guy and we're going to get him pretty close to the first intersection. It doesn't matter which order you find these. You're going to click enter 3 times and you're going to find out that one of your values is going to be 2.6180, and then of course plus your 2 pi k. Don't forget about that. And then we have to go back and find this intersection as well. So you're going to press second trace 5 and you're going to jump left until you get pretty close to the other intersection. And once you get there again, once you get pretty close, you're going to click enter 3 more times. And you're going to get your other value of 0.5236 plus 2 pi k. So, and then a nice thing that you should do is sketch the graph just for yourself. The graph looked a little bit like this. And then you graph your other one, and then just make sure you know that you're getting those 2 values. And that's it. That's all you have to do. But a little bit of pre-work again. You've got to do your crest, your trough. You've got to have your X-min and your X-max, because if you don't have that set up in your calculator, you might see 4, 6, 8 different intersections. You need to know which 2 to pick, and it's got to be based on your start and stop and your crest and trough. Okay? So, let's move on to the next example. The only difference you have to do with this example is it has a different window. So, you need to start out with your 4 times x minus pi over 2. And that, of course, is between your 2 pi and your 0. And you're going to divide everything by your 4, so that's going to give you 0 is less than or equal to x minus pi over 2, which is less than or equal to pi over 2. And then add pi over 2 to both sides, and your start, or your x minimum, is pi over 2. And then your x maximum is going to be pi. And now you've got to find your node crest trough amplitude. So your amplitude is 2. So that means if we have a node of y equals 1, your crest is 2 above, so your crest is going to be 3, and your trough is 2 below, so it's going to be a negative 1. So now you have your x max, your x min, your y max, your y min. All you have to do is use the calculator again. So why don't you pause the video and try to find these answers on your own. So with all this set up here, you see you're going to have 2 answers down here. Your f of 4.3, you just type that in the calculator, look at the table, and you should get your 0.8426 if you did that correctly. But now this f of x is equal to a negative 0.3. You are going to have a little bit of a different answer than me, most likely. So x is going to equal 2.1404, and you should have had 2.5720 plus, and here's the new trick, it's pi over 2k. You have to use your period instead of your 2 pi. That's the only difference. So if you got everything except for that, you're good to go. It's a new little twist. I wanted to see if you can do all the work without my help. So if you got these numbers here, you're good to go. Only difference is when you're solving with a calculator, your period is what you're going to use for your plus, whatever k. It's not 2 pi k for everything. That's when we're doing them, by hand and stuff. So that's it. So you have 2 more examples to practice. Why don't you pause the video, try both of those examples, and if you get the correct answers, you are good to go. And that's it. So go ahead, pause the video, give them a try. All right, here are the examples that you were supposed to try on your own. All you had to do is use your graphing calculator correctly, so check your answers. If you got them correct, you are good to go. If not, go back, watch the video, and find out what mistake you went wrong on, and have a good day. This is Longo, I'm out. See you, bye.